Section 5.3 is talking about more bisectors, but you're going to find that the perpendicular bisectors and the angle bisectors will intersect at a specific point. So up at the top, it says when three or more lines intersect at one point, they are concurrent, and the point at which they intersect is the point of concurrency. So this first theorem is saying the perpendicular bisectors of the sides of a triangle, so that would be these lines here, those are concurrent at a point, which is point P, so concurrent meaning that's where they intersect, and that means that from that point to the vertices, those line segments are going to be equidistant. So I have perpendicular bisects to these lines. Where those perpendicular bisects intersect, that point to my vertices are congruent to each other. The point of where these perpendicular bisectors intersect is called the circumcenter. So you might put a star or highlight or something around this word because you're going to have to know what circumcenter is. I also gave you this brief description just so you know about circumscribed about. So since the circumcenter is equidistant from the vertices, which is what this theorem up top was just discussing, you can use the circumcenter as the center of a circle that would contain each vertex of the triangle. So this would be the center of my circle because the vertices are all inside of the triangle. It'd be like if I put my compass point here and drew a circle. And then they say that that circle is circumscribed about the triangle. So just a couple key points that if I have a circumcenter, if it's an acute triangle, the circumcenter will be inside. If it's a right triangle, my circumcenter will be on the triangle, and if it's obtuse, then it's outside. So you may make just that note so that you know what these pictures are indicating. For acute, it's inside. For a right triangle, it's on it. And for an obtuse triangle, it is outside of it. Just for you to have reference. And the reason I say that is because in this first example, you have to find where your circumcenter is. So let's take a look. It says, what are the coordinates of the circumcenter of the triangle that has these vertices? So the first thing I did was I graphed these vertices. So go ahead and do that. You have to find the circumcenter, which is the intersection point of the perpendicular bisectors. Well, you only need to find two of those perpendicular bisectors because there's no sense of doing a third. It's still going to intersect in the same spot. So, step one is you need to find the midpoint of one of your legs and then find the line that is perpendicular to that leg. So, for example, let's start with PO. This is my leg. I'm going to count the length. 1, 2, 3, 4, 5, 6. The length is 6. So that means my midpoint has to be at 0, 3. So I put a point there. If I'm going to be perpendicular to this line, I'm going to have to be going the opposite direction so it makes a right angle. Well, if this is a vertical line, then I'm going to make a line that's horizontal going through that point. So that's what I did. I drew in this line at y equals 3. Now we're going to do the next leg. So you don't want to mess with this hypotenuse because it's going to get kind of messy in finding it. So just do the horizontal and vertical lines because it's a lot easier. So then we're going to do the other leg. So OS has 1, 2, 3, 4 as a length. So therefore my midpoint is at 2. So I put a point there. And then I'm going to want to draw a line that's vertical because that's going to make it perpendicular to OS. So you just drew in two perpendicular bisectors for this triangle. Where that intersects is going to be your circumcenter. So where they intersect at is my answer. So my answer would be the coordinates of this intersection point, which is 2, 3. Now there is a lot going on in that problem. I understand that completely. So you really need to probably rewind, watch it a second time, watch it maybe a third time, and then make sure you kind of got the handle of it before you go to the got it question. So if you're ready, go ahead and go to the got it question. So in the got it question, you're doing the same thing. You have to find the circumcenter. So your first step is find the midpoint of one of your lines. So if I did this top one first, 1, 2, 3, 4, 5, 6, 7, 8, it's 8 long, so I'm going to count over 4 spots. So that means I'm going to be putting a vertical line through this spot here so that it's perpendicular. Then I'm going to do my other leg, which is 1, 2, 3, 4 boxes long. So if I cut that in half, my midpoint would be at this blue point. And then I need to draw a line that's vertical to my leg, so that's why I'm going to draw a line horizontal going through this point. Where these two intersect at is my circumcenter. So I would write the coordinates of this point because that would be where my circumcenter is. So my answer is 6, 5. Okay, so the first part is perpendicular bisectors always intersect, and it's called a circumcenter. Alright, so then the second part is what happens when I have angle bisectors, and what is it called when it intersects? So this says that the bisectors of the angles of a triangle, so angle bisectors, are concurrent, which means they intersect, at a point that is equidistant to the sides. So that means that all of these dashed lines are equal to each other. Important vocab, so maybe highlight, star, do something to this that's down here. The end center is what this point is called when your angle bisectors intersect. So it's the point of concurrency of your angle bisectors. The end center will always be inside the triangle. Doesn't matter what kind of triangle it is, it will always be inside of it. Okay, one more example to go through here. So using that last theorem, you have this triangle. They give you what GE is, GF, and it asks you to find GD. So I look at my picture. I see that I have angle bisectors, and I see they all intersect at point G. So the last theorem said from point G to each side, these lengths are going to be congruent to each other. So I went ahead and wrote in the expressions that they gave me for GF and GE. So if all three of these lengths are congruent, then I can just set these two expressions equal to each other, which is what I did. So I did 2x minus 7 equaling x plus 4, and then I started solving. So I subtracted x, added 7, and got x equal 11. Again, it's not asking for what x is, it's asking for the length of GD. So remember, they don't give me an expression for GD, but think to yourself, how would I be able to find that? Well, GD is the same length of any of these other ones, so I just picked one, which I took GE, and I took this expression and put in 11 for the x spot. So I did 2 times 11, which is 22, subtracted 7 and got 15. So that means that GE is 15, and then also GD has to be 15 as well. Okay, you're going to pause the video and try the got it question. So in the got it question, again, I see angle bisectors. So that means that QN, QO, QM are all congruent to each other. So they gave you QN and QM, so I set those two equal to each other. And then I started solving. So I subtracted 2x. I then got 3x plus 36 equals 51. I subtracted 36, and so I got 15. And then I'm going to divide by 3, and I got x equals 5. It's asking for what the length of QO is. Again, I don't have an expression for QO, but I do know that it doesn't matter which expression I use because all of these are going to be the same length. So I just took one of them, and I took the QN expression, and I put 5 in for x. So 5 times 5 is 25, add on 36, and I got 61. So therefore QO is also 61. Now we're getting pretty involved here because you're starting to get new vocab, but then the pictures have a lot going on in them. So try and decipher on what pieces are congruent and try and get that stuck in your memory just so every time you see a picture you can kind of mark that.